So to start this project, or any motion capture project, we're going to need some motion capture, and to do that we're going to need a motion capture system. Now optical is not really a solution in here. This room's about 2 meters square. I also don't want to be drilling holes in my wall to mount cameras or putting up scaffolding and tripod. Also, if I need a little bit more space and I want to go out onto the landing, then that means I'd have to set up some cameras on the landing or try and run 2 systems. It's just not possible. So for this project I'm going to be using an Xsens MVN system. So this is an inertial system which is different to optical. I'll explain how they work differently later. So I've been using one of these systems since about 2008 when we've used it on a film called Paul. Since then I've used it at the studio, I've used it on set, I've used it indoors, outdoors, and then more recently I've been using it at home like a lot of people while I've been working from home. And full disclosure, this video isn't sponsored by Xsens. I reached out to them and asked if they'd be kind enough to let me borrow one of their systems for this project, and they were kind enough to say yes. So in return I'm making this video to show how I use the system, and hopefully it'll give you some tips and tricks if you're already using the system yourself, or give you a better idea if you're planning on using one of these systems on your next project. In this video I'll take you through the entire process from start to finish in pretty much real time. So we'll look at wiring a suit, calibrating the system and capturing some data, and we'll look at some data examples, different processing types and how to export the data ready for editing. And then at the end I'll show you how to set up the stream so you can stream data live from MVN Studio into MotionBuilder, similar to the setup that I had at the start. And there are a couple of things I won't be covering in this video. One of them is setup, because unlike an optical system there's no cameras to set up or calibration ones to do and things like that. It's pretty much plug everything in, turn the power on, open the software, and you're more or less ready to go, so there's nothing really to see. And the second thing is measurement. Now unless you're really accurate with these measurements, it can really affect the quality of the final data that you get out of the system. So the safest option is just to use the body height and the foot sizes, and then let the software estimate the rest of the values. And one last thing, this video is pretty long, so I've left some timestamps in the description below so you can jump to the section that you need. Okay, let's get started. So the first thing you're going to do is lay the suit out nice and flat to make it easier to wire up. And then we're going to open up all the zips. So what I usually do is I usually lay the suit so the head end is on my left, then I know that the pockets closest to me are the left hand side of the body, and the pockets on the other side, the right hand side. That way I don't have to think too much about what I'm doing when I'm wiring things. It's one less thing to think about. And hopefully it helps me stop making mistakes when I'm putting the suits in, when I'm putting the sensors in. So the first thing you're going to do is move this up, and then we're going to wire up the legs. So the legs and the arm come in chains like this. So you have 3 sensors on a chain, and this one's a right up leg. So because I've got the head facing that way, I know this side's the right hand side. So you're going to put in the first sensor and just stick that in the middle of this Velcro patch, because I know that's going to be roughly in the right position. And then the next one we're going to put in is the one for the shin, and this just fits in down here. And then the last one is just a placeholder for now. So I put 2 loops in this, and then just put this down here. So like I say, this is a placeholder for now. This isn't where the sensor goes when you've got somebody in the suit. This is just to hold it in place while they put the suit on. And the wires that I've got at the bottom here, you just need to make sure they're tucked in below this sensor. Otherwise, if they're round like that, when you come to pull the sensor out to mount it in the shoe, it's going to get snagged on this sensor and you won't be able to pull the wires out. So you just need to make sure they're below that sensor. Make sure the wires lay nice and flat, and we can zip that leg up. And we do the same on the left hand side. So same thing again, we get our left sensor, left leg up sensor, place the one for the thigh, and then just put a small loop in it, place the one on the shin. The reason I put the loops in is, one, so that the wire stays nice and flat, so there's less chance of it getting snagged, and also it's more comfortable for the person wearing the suit that they've not got big tangles of wire pressing into the skin. Because you'll see after you've worn this for a day, you'll see these wires leave marks on your skin. So what you don't want is lots of tangles and big lumps and bumps, and makes it uncomfortable to wear. Also, if you've got a loop, when the wire stretches, it'll actually pull apart rather than pulling on a section of the wire. So it just makes it a bit better for use. Then the next thing you're going to do is the top part of the body. So the arms have the same strings as the legs, so the same 3 sensors. So we're going to start with the shoulder at the top. So you just thread this wire through the top of the suit, and then just inside this zip here there's a Velcro patch, so this mounts it on the shoulder. This is quite a small patch, so put that in first. Then we can put our loop in again, and put our bicep tracker in, and then the final one, loop's already in for the wrist. We can fit our wrist in, and we can zip that pocket up, and we can come and do the left hand side. Get our left arm string, and same thing again, we can push this through here, pull the wire through, and then same as the other side. If you just put your fingers behind that flat, you can make this Velcro patch sort of stay flat so that you can get a much better stick when you put the sensor on. And then same thing again, just get our loop, put that flat, tip that in, and we put our wrist in. So that's our arms and legs wired in. So the next type of sensors are these single sensors. So we have one for the sternum or the chest and one for the pelvis. So the sternum one is the only one in the suit that you have to thread. This goes in here just by the front of the zip. So in the old suits you had to thread all the wires through pockets like this. So you can imagine it took a lot longer to wire a suit than these new ones with the zips. It makes it much easier to wire a suit. And then for the sternum and the pelvis, they both have these plastic plates to hold the sensors in place. So you can fit them nice and tightly in there. You can fold that up. And then you just need to make sure there's enough wire, there's a little bit of give in here, so that there's plenty of room around the neck. Because when somebody's putting this on, they're going to make a lot of stretching around the neck as they try to put it over the shoulders and things. So it's worth leaving just a little bit so this doesn't get pulled out of place. So we have our chest in. And the last sensor to put in is the pelvis. This lives just down here. This goes just at the base of the spine when you're actually wearing the suit. And again, there's a nice big plastic mount to put it in. So you can put our sensor in there and just run this up the back for now. Now we've got all our cables in, we can start putting in the connectors. So there's 2 connectors, both have the LEMO connectors on the end. So you've got one with 3 strings and one with 4 strings. So the 3 strings is the one that connects the lower part of the body, and the 4 strings connects the upper part of the body. So what I usually do here is I take the string with 2 connectors on, because this is actually slightly longer. So I use this to go further down the left hand side. So you can put this connector through the center, and then I just like to clip it in place using the Velcro. That just means when I'm actually wiring the suit and pulling the wires around, this doesn't come out of the pocket. So then I can take my wire to the left leg and just feed this through here. And then here, this is probably one of the most important ones to get the loop on, to make sure there's a good loop when you connect them. Because this has to stretch so far, this is going basically from the top of your leg up the side and round to the back. There's quite a lot of distance, so you get quite a lot of stretching as people bend. So what you want to make sure is the wire stretches like this around this loop. What you don't want is for the wire to get straight and then you're pulling on these connectors and it pops apart, and then the recording will stop. So if you don't do any of the other loops, make sure you get one when you do the legs, just to avoid it popping apart. So we've got our left leg in, then we can thread our right leg down this side, and again just lay this flat, make sure that plays nicely, and lay that flat, put that in that pocket, and we can zip that up. Now you can do the top part of the body. So again, I'm going to put the LEMO, forgot a connector, and then we just need to connect our pelvis to the bottom part of the body. So when I'm doing the pelvis, what I try and do is connect it, rather than connect it so that the connection points down here at the bottom of the pelvis where people sit down. What we found is sometimes when people sit, and they sit in a chair, this will actually bend round, or for certain stunts and rolls and things, you're putting a lot of pressure down here because that's where the main part of your back bends. So what I try and do is mount this sort of in the middle of the back so that it's away from the bottom of the back and more sort of around the middle, which is a bit more, stays a bit flatter, and there's less chance of catching it on a chair and things to pop that sensor open. So now we can do the top part of the body. So this is the LEMO connector again. We can put this into the pocket in the same way and just fasten it in with the Velcro. And then on here we've got 2 strands. So what I like to do just to keep things organised, I take the 2 strands together and connect the 2 arms. And the right shoulder. And then I'll leave one out for the head, and then just loop this second one round, and we'll grab our sternum connector and put that in. So you can see here, by looping those wires around, it just means they lay nice and flat. So when your performer's wearing the suit, because they're laying nice and flat, it's a lot more comfortable for them to wear, especially if they're going to sit and lean against something. You've not got lots of wires poking out at different angles. It just lays a lot flatter. And then, now we've got our suit all wired up, we've got all the sensors connected, we can fasten this up, and then normally I'd fold this up, and this is how I take it on set so that it's ready to go. So somebody could just put this on, then we can just attach the head and the hands. But because I'm going to be doing this on my own, the extra bits I'm going to do is connect some of the other pieces up. So normally, like I say, I wouldn't have these in the suit because it makes it a little bit more difficult to get on. But because I can't do this afterwards and wire the suit myself, I'm going to do this now. So the first thing we're going to do is put the battery pack in. So that goes on the left hand side, and then this cable threads underneath here and comes out the other side. And then the other one is to connect the transmitter pack onto this side. What I try to do when I mount these, when I'm mounting them when somebody's actually wearing the suit, is to try and mount them towards the edge of this Velcro. So it just means that it's positioned further around the back, so you've got a much bigger space in the middle of the back if they're going to sit down again on a chair, or if they're going to do rolls. There's much more space between here, so they're not going to be rolling, there's less chance of them rolling on the packs. So now you've got our packs in place, you can uncouple those. You've got the LEMO connectors, these can go in any of the 2 ports here. And then the battery one is a completely different size, so you can tell which socket that goes in. So you can zip those in. And then the next one I'll put on is the head. So we'll put that in the headband. And then connect that to the head. And then I'll just pop this in here just out of the way. So when I want to put the suit on, I can put this on, this will stay out of the way, and then I can get it out when I've actually got the suit on. And then for the 2 hands, I'm just going to connect these like this, and then I'm just going to roll this up and put it inside the suit. So this means when I want to put the hands, when I need to connect the hand sensors, the actual sensors are already connected, I just need to put the gloves on, and then I'm good to go. If you're trying to connect, because you need 2 hands to connect these sensors, now this is very difficult to try and line that up and do with one hand. So it's easier to connect these now and put them in the suit, and then when you want them, if I just zip this up, if if you imagine now, if I had this suit on, I can just unzip this, take the hand sensor out and put it in the glove, and it'll be in place. It's a lot easier than trying to connect it with one hand and do it that way. So then we can fold this up, put that back in there, and then fold this up. And then we have our suit all wired and ready to go. So to get started, we're going to come up here, start a new motion capture session. That brings up our configuration window. So in here we just need to make sure our system's turned on. And then we can change the system name to the actor name, so we know which actor's wearing the suit. And suit configuration, we're going to use full body, because we want to capture the full body, not a lower body or upper body. And then scenario, we're going to leave as single. You can actually change this while you're recording. So for different sessions you might want to choose a single level for somebody that's on the flat, or multi-levels, things like in a chair or walking up and down stairs or stepping on boxes and things. No level puts them sort of at the centre of the scene and makes them floating. So if you're doing sort of flying and things like that, you'd use no level. And then soft floor is more for mats. I don't really use that one at all. But for now we're going to leave this at single level. And then accept system we can leave as any. So this will just pick up the system when you turn it on. And then body dimensions, we're going to need to put in our body dimensions. So I've already got these saved. So we're going to use mine. So that sets the body height and all the different dimensions. And then we just need to select a folder to save in. So I'm going to use the MVN folder and select folder. And then in here, we can just call this, so we can change this to test action. Then I usually leave _t at the end, because the software will actually add -001, an auto increment, so the next take will be take 2, next take will be take 3, and so on. So I just usually leave _t at the end, so I know which take it is. So once we've got our session configured, we just need to wait for the suit to connect. Once it does, you can see here you get a ready for all operations message up here, and all the trackers show up as green, which means they're connected and ready and working. So we can OK that. As you can see here, I'm actually leaning over a desk. You can see here, well, for a start, my head's upside down and the hands are at funny angles. So to fix that, we're going to need to do a calibration. So if you come over here, we're going to do a end pose and walk calibration. And because I'm doing it on my own, I'm going to use a hands-off calibration. So this will give you a delay to when it actually starts calibrating. So you can set this up to 16 seconds. So we'll just leave it at 6 for now. And then we can hit calibrate. And this tells you to get into the end pose. So the first thing I usually do is use this template that I've made. So what this does is it gets the feet in the correct alignment. So the bit down the middle, make sure the feet are aligned facing forward, and that also they're the correct width, so the foot spacing is correct. And then the bar across the back means somebody can put the heels against it. So just make sure the feet are level, the toes are level. So once I've got the feet in the correct position, the next thing we need to do is make sure the spine's in the correct alignment. So I usually ask people to do is stand up straight, but not to attention straight. Usually when you ask people to stand up straight, they'll sort of do this to attention, which puts a curve in the spine like this. The problem with that is the software then thinks this is straight, and when the person relaxes, their body will drop forwards. And that means when you then transfer that onto a character, the character will be straight, but then it'll have this slump forward kind of action. So what you need to do is ask somebody to stand up straight, but they're natural, sort of relaxed straight. And the next thing, once you've got the spine straight, is to align the arms. So what I usually do is ask people to make a fist, to put the thumbs up, and bring the thumbs up to the shoulders, keeping their elbows in, because they tend to bring their arms up like this. Make sure their elbows are in. So just make sure the elbow bend is at the correct axis. So the software expects the bend, the rotation, to be facing outwards. So by doing this, you're just putting the rotation on the correct axis. So bring these up, put these down. Then I usually get them to make a fist, because that means when they put the hands down, they can put their fists against their legs. So this holds the hand in place. It also makes sure that the hands are at roughly the right angle. So when this comes back, you don't have hands that are slightly turning. If they use flat hands, sometimes you can get slight movement in the hands if they're not holding them still. And also they might not be the correct angle, but this seems to give a pretty good balance for both of these. Once you've got the arms in the correct position, the last thing to check is the head. So what you want here is for the person to be looking directly ahead, and then not tilting, squashing their head back. So sometimes people stand, and because you've told them to fix their head, they tend to lift it backwards, and sometimes they'll be looking either down the nose or straight ahead, sort of underneath their eyes. So you want to make sure that the eye level is nice and straight and that they're looking straight ahead. And once you've got that, you can go through the end pose calibration. So the software will actually show you what you need to do at each time, and it'll also count you down in seconds for when you need to change and run you through the poses and what you're supposed to be doing. So you can actually show this to people while it's running if you need them to follow what's going off. One thing I have noticed doing it on my own, because there's no noise, you can see that unless you can see the screen, you have no idea when the calibration is actually starting. So what I've been doing is zooming in nice and close on one side so I can see when he starts walking. So if I set this to trailing, it'll follow him. And then we can hit start. So you can see you get a moment standing in an end pose. And now it'll take you through the calibration process. So you start walking, you'll walk forwards, turn around, and then walk back. And you can see all the time it's counting down here and telling you what you need to be doing. They need to come back and stand in your end pose. And then once the calibration's done, it'll tell you whether it was successful, and you'll get any error messages here. So if you've done something wrong, like arms moving is quite a common one, it'll show you in here. And then to apply this, we need to get back into the end pose position and then apply it. So to do that on your own, you need to accept and then get in the end pose. And now you can see, now that's been applied and now been calibrated properly, the joint positions are much better. The last thing you need to do just before you finish this is to make sure you hit save. So this is going to save your calibration and the body dimensions that you've used. This just means if the software crashes or something happens, instead of having to do the calibration again, as long as you don't take the suit off and put it back on, you can select that and just hit load and it'll reload the calibration. So once a person's finished the end pose calibration, the standing and walking up and down and coming back, what I like to do is get them to perform a set of actions that, one, check that the calibration has been successful, and two, helps the software build up some data, some good quality data that it can use to refine the tracking to improve the quality of the data you're going to get out of it. So what I usually start with is making sure that the arms are correct, so I get them to stand in a T pose and then fold their arms across the chest. So what you can check here is that the arms aren't calibrated too far backwards and that they're actually rotating, that the elbow's in the correct axis, rotating on the correct plane. And then the next one I get them to do is just lift their feet. So I start with just lifting a left leg behind them and then lifting the right leg. This just again makes sure that the knees are rotating on the correct plane, and also that you've put the hand sensors and the feet sensors on the right way round, because you will do it the wrong way round. I've been doing it 10 years and I still, every now and again, they'll pick one foot up and the wrong foot will move. And then the last one I get them to do is part of the old calibration. I get them to bring their hands together and then just bend them in and then move them around. So what this gives you is a good bend across all the hands, and this just helps improve the hand contacts. And then finally I'll get them just to repeat the walk, so that's usually towards me or down the room, the same walk that you do in the end pose, just to walk down and walk back. What this is doing is it's giving you some good quality data, so there's no like high impact stuff running around or jumping. This is just nice steady data that the software can use to improve the filtering that it uses to get the best quality data out of the end. So an inertial system works in a slightly different way to an optical system that most people are familiar with. So in an optical system you have the little shiny silver balls, the tracking markers, and they're placed on the outside of the suit, and then the ring of cameras calculates the position of those markers in space. On an inertial system, the trackers are actually placed inside the suit. So this is a tracker from an inertial system, so this is an inertial measurement unit, or IMU. So these record the rotation and the speed of the rotations, and then these are placed on each limb on the body. So these are now recording the rotation and the speed of the rotations for each limb in the body. So there's one on the hands, one on the lower arms, upper arms, shoulders, head, top of the chest, base of the spine, upper legs, lower legs and feet. So each tracker has a unique ID. So when it sends the information from the tracker back to the software, inside the software knows what the ID of the tracker is and then where that's placed on the body. So if we look at the right hand here, we can see it has its own tracker number, and then it has the right hand. So then the tracker actually records the rotation and the speed of that rotation. So you can see here on the hand, as I move my hand here, you can see it moving in real time in the software. So it does that for each limb in the body, so it can then record what limbs, it knows what limb's moving and how fast it's moving. So because the system can't see me, it doesn't know where I am in space, The way it does that is it uses the skeleton height that you give it to build this skeleton, and then it knows where all my joint positions are. So it uses that to calculate how long my legs are, how big my feet are, and then it can use that information to calculate my stride length when I take a step. If I do it this way, then you can see it. To take a step, and it uses that information then to figure out where I am in space. So when you start the software, it puts you at 0, 0, which you can recenter in the software. Then as you take a step away from that, it then uses your stride length to calculate where you now are in space. And then as you move around, it continually updates that information using the foot floor contacts and your limb lengths. And one of the things that people often think is because it's using this foot floor contact, you can't actually leave the floor, that you have to stay rooted to the floor. But with the movement system, this isn't the case. You can actually jump and it's fine. The floor doesn't stay stuck to the bottom of the feet. And with this software, you can also set it to do what they call multi-level, so you can do stairs and steps and things like that, and it'll solve the data correctly. It's not super accurate, so if you have a 20 centimeter step, the step that it takes might not be 20 centimeters, but you will actually step up in space. And then when you're ready to start recording, you can come up here into the configuration window again, and we can change the file name. So you can give this something like we can change this to character name, and then underscore take name, and making sure we leave that T at the end. Then hit OK. So at this point, this is normally where you actually go and get into their first positions, but as I can't do that and hit the record button in the software, what I'm going to do is I'd hit the record button and then get into first positions and perform what I need to do. Hit again to stop recording, and straight away you should see your file pop up. At this point, the green progress bar at the bottom is the data just sorting itself out, so it's worth waiting for that to finish. And then when you close it, it will also ask you if you want to save it. So you want to make sure you save that data. That green bar is just making sure all the data's in the right order and that it's got everything that it needs. So it is worth saving that when you do it. Otherwise, every time you open the file, you're going to have to wait for that green progress bar to run through. So it's worth saving that. And then the next time you load it, you won't have to wait for the green progress bar to finish. Once you finish recording, the file should pop up to playback. So you can just turn on loop playback and playback in here. If it doesn't, you can come up into options and preferences, and in here under recordings you can turn on automatically open MVN file after recording. There's a little tick box here, so you can just turn that on. Another handy one in the user interface is you can change the frame time format, so that's displayed down here in the corner of the screen. So you can change this to frames, or you can have it as timecode if you're recording timecode. So save that and close that. And if you did want to record timecode, that also lives under options. There's an audio LTC decoder here. So you can see here, you just give it a source. And then if you're using, I'm just using an iPhone app, but if you had a actual timecode generator, you can plug that in to the computer and then it'll read the signal that's outputting. So you can see here, it's actually reading in the timecode. So when you're recording, it will record with timecode. So that's if you want to sync with head cams and sound and things afterwards, it will actually record a timecode into the file as you're recording. So like I say, once your file's finished recording, you can come up here, turn on toggle repeats. This will continue to play back, and then we can play our file back. And then in the window, you can left mouse button and move around. You can zoom in and zoom out. You can also pan the camera as well from its current position. Another handy feature, especially for this file where they're moving over different levels, you can turn the floor on and off. You get a little shadow. So for this, it's quite handy. Obviously, if you're on one level, you can leave the floor turned on the whole time. But like this, where I'm actually starting and coming upstairs, we can turn the floor off so you can still see the character. It doesn't disappear under the floor. So if you were jumping down, you could turn the floor off so you can see your character fall through the floor. Another handy feature is you can change the playback speed. So obviously you can turn this so that it's only playing back at half speed. Or you can speed things up if you need to. Go back to double speed. And then let's just change that to back to 1. And if you just wanted to play a specific area of the file back, so you wanted to just watch this walk upstairs, we can select this walk upstairs here, and then in the playback there's a little drop down, you can play back the section. So this will now only play back the section that's highlighted in blue. So if you wanted to review this section, you can then just play that section back, and then we could look at it at quarter speed, just make sure everything's working as it should be. And the next thing you'll want to do, once you've checked the file playback, you can come up here and you can use the reprocessing tools. So in here you can change it from normal to HD. And then in here we can change the user scenario. So this is set to multi-level because I'm walking upstairs, but you can change it to single level, no level, and then reprocess the file using these. And then hit start and close and it'll start reprocessing the file. Obviously I'm not going to sit here because it takes roughly about 10 times the length of the file that you've recorded. So if you've recorded a minute, it's going to take it at least 10 minutes to process, and I don't think we just want to watch this progress bar going. So to stop it, you can actually come back up here and stop the processing and then close. And so next we'll look a little bit more at processing. So I thought the best way to look at the quality of the data you get from our MVN system and the different scenarios to use and processing and things would be to capture some example files. So we'll start off with something nice and easy with a walk. So on the left here we've got an unprocessed walk. So this is standard definition, do you want to call it that? So this is pretty much what you get raw out of the system, what it would look like. So you can see here it's not done a bad job. You can see there's a few wobbles in the foot floor contacts there, and you can see here it's quite spongy. So these are just some different tests, different speeds, changes in direction, just to test how well it picks up the different floor contacts and things. So if you compare that over here, this is our HD version. So this has been reprocessed in using HD processing. So hopefully now you should see the foot floor contacts are a lot more solid. There's a lot less sort of strangeness in the way the foot's coming off the floor. And if we look at our little test back here where I've done the quick little steps, you'll see the foot floors. See the floor's much more solid. Then these changes in direction, you can see the feet stay planted to the floor. So if we just play these two back at the same time, you should hopefully be able to see the difference. So this is a fairly straightforward processing. Usually for single level like this, I'm walking around, standing, you can pretty much process everything on HD and you'll get a much better quality. So if you compare now these footsteps in the two, you can see they're a lot stronger. And the way the feet are contacting with the floor and the changes in direction is a lot better on the HD version. So in this example, we're going to have a look at some multi-level processing. So this is me stepping up on top of the box the MVN system comes in. So on the left, we've got our standard definition raw capture. And then on the right, we've got our processed HD version. So you can see here, it's not doing a bad job of actually stepping up on here, even with a jump. But on this second one, you can see I sink back to the floor. But you can see once it's been processed with the HD, it actually gets the right height. And you can see I keep stepping up and down. And that works fine, jumping off the box, jumping up and down. It's fixed all those problems. So again, when you're standing up, even on multi-level stuff, you can see here, most of the time, the HD is going to be the one that you want to use to fix any problems that you've got in your data. So now this is another example of multi-level use. This is me going up and down stairs. These are a domestic staircase at home. So what I'm doing here is just standard walking up and down. So on our left again, we've got our standard definition. And on the right, we've got our HD multi-level processing. So you can see just on normal walking up and down, even in the raw sort of capture side on the left, the system's doing a pretty good job of selecting the right foot floor contact and making sure that the character goes up and down on the stairs. See a slight little wobble. So then I tried to confuse the system by just taking multiple steps in different directions quite quickly, just to make sure that it's actually picking the correct foot to lock to the floor. Now this time I go up and I do double steps, and you can see here where I've gone up two at a time, you can see it's now picked the wrong foot and you get that squashed effect. So our character is no longer on the right floor. But if we look at our HD processing, you can see where it's gone back through and processed that. It's actually picked the right floor. It's actually picked the right foot to be on the floor. So we're still at the correct height here. Then you see when I go up again and on the top I do a jump, you can see then it really gets the floor wrong. But after it's been reprocessed in HD, that's all fixed. So you can see a lot of the time for your multi-level stuff, again for walking, processing in HD is going to fix a lot of the problems that you might have in your data. So in this example, we're going to look at multi-level processing, but this time for chairs. So it's not necessarily what you'd think of as a multi-level thing, but because you've got your feet and your hips are at two different levels, it does actually work better with the multi-level. So one thing I have found is in SD, it does actually seem to do the legs sometimes when you've got them crossed a little bit better than it does in the HD. But the thing that it does correct a lot better in the HD is obviously the foot floor contacts are a lot more solid than the hips. There's less bouncing, as you can see. So that's a sort of example if you're doing a drive-in. But you can see you can pick your feet up off the floor and it doesn't sink back down and crash into the floor. It actually stays in the position like you sat on the chair. And again, just a relaxed pose, but you can see this foot's now off the floor, whereas this one is still solid and back on the floor. And changing legs again, this one stays solid on the seat, but you can see with this one there's a lot of up and down and the foot comes off the floor. But you can see even just shifting weight and lifting your feet off the floor, even in SD you can still get the actual pivot. The hips do drop up and move up and down a little bit more than they do in the HD. Obviously quite a bit more in there, but you can see it. And then for standing up and sort of reseating to make sure that it's picking the right contact points as they transfer from the feet to the hips to the hands and then back onto the feet. It still does a pretty good job in the SD, but obviously the HD is just a lot better. And you can see then on here, even lifting the feet off the floor, it's much more stable. So in this example, we're going to look at sitting on the floor. So this is where things get a little bit more tricky with the MVN system when you've got multiple contact points on the floor. So if I just start these playing, so you can see in this one I've actually sat with my feet on the floor. So you've now got 3 points of contact. So starting at the top left here, we've got sitting, so this is on single level, and then single level in HD, and then bottom is multi-level processing, just to give you some idea of the differences that you get with the processing. So what you'll start to notice is, especially in this cross leg pose, you can see some of them handle better. So the multi-level HD, you can see it doesn't really do the legs very well. They start to drop below the floor. And then we're getting the same in the HD processing on single level. But in multi-level in standard, you can see the contact with the floor is much better. There's a lot less intersection and it seems a lot more stable. So it's not always an easy case of just picking HD, and in this case you'd think it's on a single level. This is another place where it goes slightly differently. You get different results depending on which type you've used. So you can see here in the standard definitions where I've turned, I've actually got my legs together. So I was actually sat like this with my feet together. So you can see in these two standard definitions the legs are correct, but you can see in the two over here in the HD versions the legs have actually crossed over, which isn't the correct pose. So it's not always a case of just picking HD and that's going to give you the best results. Sometimes you may have to do things in the standard definition or normal to get the better results. So if we continue playing now, you can see, although it's not very stable, these little pops are probably going to be easier to get rid of than actually changing the whole position of the feet. And you can see it's still having contact issues with these feet, where it's trying to solve where the heels should be and they pop up and down. So the last thing we're going to look at is laying on the floor, which is probably the trickiest thing most motion capture systems have to handle, but for the MVN system it's probably its trickiest one because of the multiple contact points you get in the floor. So in this example we've got the standard and HD on the single level on the top, and then on the bottom we've got the standard on the left and the HD on the right using multi-level processing. So you can see the different sort of artifacts you're going to get. So you can see here on the single level you can see the feet are bobbling up and down, but you can see over here you get a lot more intersection with the HD. And then when I roll onto my side now, you'll see how the different systems handle the floor intersection. So you can see on this normal standard definition the knee's gone into the floor, but you can see on the HD the knees are all above the floor. And it seems to have a better sort of contact between the hips and the shoulders, the knees and the feet, than we get in with the standard definition. We continue playing. As I adjust, you can see this is staying pretty stable. In all the different processing, you're just getting slightly better contacts. And when I lay on my front, you'll see things get a little bit weird, depending on which system you've used. So the HD sinks below the floor on the multi-level, and then the other two, the hips seem to raise and go up above the floor while I'm actually laying still. And then you'll see as I start to, they all start to drift back into position as I start to move again. The weird thing is, if you stop this, if I go back to here, so if I turn the grid floor off, you can see here where I stay still, the character drifts down and then comes back up. But if you actually look at these two positions, so this is where I start to get back up, this is where I got into, you can see they're pretty close. So what you could probably do is just trim this drop out until I start to get back up. And you see that in quite a lot of this. If I go to the same frame on all of these, let's go back to where I start to sync. So you'll see a lot of these exhibit the same sort of behavior. So you can see here the back of me drifts up on this one and then comes back down as I start to stand up. So again, if we look at that frame compared to that frame, you can see they're pretty close. So you could probably just edit out the drift that you're getting in the hips. And then in this file, same thing again, you can see as I'm breathing, it's actually moving and drifting again. But with the SD, when you actually go between the two frames, you can see they're still very different. So you wouldn't be able to fix these in the same way. So although there's the drift, you can see the frames on either side of that are very different. So you'd have to edit this a little bit more. So if you did want to output your files using different settings and then review them like I've just been doing there, to do that, if we use this sitting test take 1, if you open them up, you'll get multiple windows. So they're all at different sizes depending on what size they were when you last used them. You come into window, you can go into tile. It'll nicely arrange all the windows like this for you. And if you want to link the views so that when you rotate them, they'll all move together, you can come into view. If you do linked views, just means then you can rotate them around and they'll all have the same angle. And if you want to play them back at the same speed, in here in playback there's global play and pause, move frames, so you can hit shift spacebar and that'll start everything playing at the same frame. So now you can review them from different angles. So this is a slightly different version of the sitting that I did. So this was just static sitting, but again it shows using different processing methods. So you've got multi-level HD, multi-level SD, single level HD and single level SD. So you can see the different results and you can watch them all at the same time and see which one's working better and which one's giving you more artifacts. So you can see here the multi-level SD again is working better for sitting than we're getting even with the HD processing. You can see this foot's drifted away and it's through the floor, whereas here it's pretty solid. So once you finish processing all your files, what I usually do is leave all the files open that I want to actually export where I'm happy with the results from the processing. And I'll come up here into File, Export, and Export all open files. And then in the option window, you can set a path where you want to export it to. Then we're going to export a type. So we're going to be going into MotionBuilder. So we're going to do it as FBX. We don't want to append suit name. If you're capturing multiple people, then you'd put that on. So it'll actually append the suit name that you've used. So in this case, it'd be Simon. But if you're doing multiple characters, then it'll add the suit name onto the end. So if the take name is the same, it won't copy over the files. So then we can come down into options. So for the exporter frame skip, I usually leave that at 0, so I don't skip any frames. Don't need to downsample. If you're going into MotionBuilder, it'll handle the 240 frames a second pretty well for whatever you're going to do, unless you're doing really, really long takes. You can afford to leave that at 240 frames a second, it'll be fine. And overwrite the first frame with a T-pose. That's just handy if you need to characterize things. So I usually leave that in. You're only losing one frame and it's usually when somebody stood around, like you can see here. I'm not actually doing anything, so that's fine. Output presets, we're going to export as skeleton. So this will give us a skeleton representation of our character rather than nodes, which gives you a set of locators. And then output units, we're going to leave as centimeters. And then the time increment, I like to use fixed because then you get a keyframe on every frame. Dynamic, you can get some strange results. You get subframe sampling and things like that, and it's just not nice to deal with. So I usually leave that on fixed frame, and then I'll start the take at frame 0. If you have used timecode to record things and you need to keep the timecode so everything stays the same, then you would put real start time and it'll use the timecode. You can just see down here in the bottom left hand corner. But it means if you brought that into MotionBuilder, then you would have a proper timecode sort of start frame. But we're just going to start these at 0 for now, so that's fine. And then walk on the spot. We don't want to walk on the spot. Once we've got all these set, we can just hit export. It'll start going through and exporting them. So another option for processing, if you don't have time to go through them, you want to turn them around quickly, or you know that they're all walking files, for example, and you want to process them in HD, you can use a batch export option. And then in here, you can set an input path, and then an output path, and then you can set your exporter type again, so FBX. And then you can change your reprocessing. So if you wanted to reprocess everything in HD quality or normal quality, you can do it here. If you do none, then it won't actually do any reprocessing. So if you've processed the files and then saved them out and saved the processing that you've done, you could leave this as none and it'll convert everything without actually reprocessing the files. Let's say you wanted to do HD quality. So parallel processors allows you to process multiple files at the same time, depending on the number of processors you actually have in your machine. So this can speed things up because it'll run 10 files at the same time. The software doesn't actually use a lot of processing power. It's more the memory. So if you've got 10 files open and they're big files, it has to load all those into memory. So you could find that you run out of memory quite quickly. So you need to sort of balance that between how big the files are and how many you want to process at the same time. So then underneath you've got the options to save the file after reprocessing. So once it's been reprocessed at HD, it'll save that version. Force reprocessing, so normally the software will only reprocess files in the lower quality. So if you've got something at HD, it won't reprocess it because it's already at HD quality. But if you've got it at SD, then it will actually pick it up and reprocess it. If you use force reprocessing, that'll force it to reprocess the file whether it's already in HD or not. And then use GNSS data is for if you've used a GNSS system when you were recording. And then down here in the show options, these are exactly the same as the ones we've just set. These do get saved each time you've done them, so you don't have to keep resetting them. They will be set across the software. So these are all set correctly. And then you can just hit export and it'll go through all the files in the input path and save them all to the output path. So for this network streaming demo, I'm going to use the clip that I showed at the beginning. So me getting out of the chair, walking upstairs, commuting to work, and sitting at my desk. So streaming this live into MotionBuilder, we're going to go up into options and then network streamer. So I've already got a streamer set up, so we'll just remove that. So first thing I'm going to do is add a stream. So this is going to be stream 1. Then the host and the port. So the host is going to depend on your machine. The port is going to be 9763. You can actually change this. We're going to be streaming UDP because we're going into MotionBuilder and we can stream at maximum. So this is a frames per second it's going to stream, so we'll leave that at maximum. And then down here, the important one here is the data streaming, which is position and orientation as quaternions. So you have to use this if you're streaming into MotionBuilder. And then the other thing that we're going to stream is the character metadata and the scaling. So this makes sure we get the name of the character and the proportions that they're using. We don't have any finger data or object tracking in this, so we can turn those off. Then we just turn the stream on and we can switch over into MotionBuilder. And then down here in our asset browser, we can come down here to the MVN folder, drag in our MVN live characters, open all takes, and then down here in devices, we can turn this on. You can see our character is now in the right position, our skeleton. So if I just set these two views up side by side, you can see now if I start playing in MVN Studio, you can see our characters streaming from MVN Studio straight into MotionBuilder. If you're doing this live, this would be exactly the same setup. So this would actually be a live performer, but it'd stream in exactly the same way. So you'll be able to see your character moving in MVN Studio and the character moving in MotionBuilder. So the next thing we need to do is bring in a character. Actually, let's just hide these four. So you can just come in here and then we're going to spacebar right click, Shift D, make sure we've got nothing selected. Spacebar right click the top node of each of these characters. Then we can Shift H to hide those. Make our viewport a little bit clearer. So now we can merge in a character. And then in here we can connect our character to our MVN character and start streaming. You probably can't notice while he's sat down like this, but if I come back down here to where this character's stood up, let's take this mid stride position. If we come down here and have a look at our character, you can see he's got these really bent legs. If we just play that through, it gives him this really weird walk. That's especially noticeable when your character's standing. You can see where he should have straight legs. If we look at our MVN character, you can see legs are straight, but these are quite bent. Now this is because, if I just expand these out, this is because when these characters are set up in this MVN live setup, they're characterized before the data is streamed in. So these joints are actually in the wrong position. So the joint sizes are different from when the character was characterized. So if we go back and put our character in a stance pose and turn off the live stream. So what's actually happening is when you stream the data from MVN Studio, it streams the joint sizes, which are actually different to what's been characterized. So the problem with that is MotionBuilder thinks that the joints are in a different position to what they actually are. So when it starts doing the retargeting, all the calculation that it's making to do the offsets between our MVN character and our actual character are wrong, and that's what's giving you these bent knees. So when we go back to this, that's what's causing these knees to bend like this. So what we need to do is grab the position of these joints and then recharacterize it with these new joint lengths. So to do that, first thing we're going to do is hide our character, and then we can turn off the live stream for a sec, and we're going to come up and turn off characterization. Now what we need to do is get the character joint sizes, so we need to stream those in and to store those positions, because if I just turn off the live, it goes back into this stance pose because there's no animation on it or anything, so it resets it into a position. So what I'm going to use is go into the character, I'm going to actually characterize it in this wrong position and then turn it off straight away. But then when we turn off our live stream, the character stays into the same position. Now the handy thing with these joints is the way they're constructed is we can just spacebar right click on the hips, go into rotation, and then we can zero all these out and it puts it in a nice T pose. And we can select our hips, go into translation, and we can just zero those out. And then if we go into a front view, we can drag this up and put the feet back on the floor. So this is now using the correct joint lengths for the characterization. So we can characterize our character. And the other last thing we just need to check is that the foot floor contacts, you can see here, get reset. So we just need to put these back in the right position and in roughly the right position. So we'll just move these out. So there's the toe. Now if we show our character, he's bent in all kinds of weird ways, but we'll sort that out. So we'll put him back in his stance pose, and then we can set him back to character, set him back to the MVN character. And now when we go back and do the live streaming, we turn this back on, you see we don't have that bent leg. And if we just switch back across, if I start streaming now, you can see when he goes back to the beginning and he does the walk, when he stands up, we no longer have that strange bent leg position. So we just come back over here. You can see here the legs are a lot straighter. So to try and fix those issues that we were seeing, you could come down here into the character settings and play with the reach and the retargeting and offsets and things, rather than doing the recharacterization. But the problem with that is you're sort of adding on to errors that already exist, whereas I think it's better to go back and recharacterize it so you're starting with a nice clean character before you start adding any more reach and retargeting on top of that. I hope you found this video useful, whether you're already using an MVN system or you're thinking of getting one for your next project. Let me know in the comments below if you have any questions, and don't forget to subscribe if you want to find out what I'm going to do with all this lovely data. Thanks for watching, and I'll see you in the next video.